Hi there. Today we'll be doing detect the only duplicate in a list. You are given a list of nums of length n plus 1, picked from the range 1, 2, all the way to n. By the pigeonhole principle, there must be a duplicate. Find and return it. There is guaranteed to be exactly one duplicate. So there's also a bonus. Can you do this in O of n time and O of 1 space? So we're going to go by the principle of getting to work, making it look right, and then making it fast. So we're going to make it work first. So from what we know is that we want to get all the numbers from 1 to n, add them up, and then that would be our theoretical max num. Let's say, and if we subtract that from the n plus 1 number, we would get that extra number. We know what it is. So theoretical max num is equal to 0, set that. And the actual num is equal to 0. So we're going to get the theoretical num first for I in range. We're going to go all the way up until n. So this would add every single number from 0 all the way up until n, except for n. Length of nums. So what this means is that we will suppose nums is 1, 2, 3, 1, like this example here. We would length of nums would be 4. We would add 3, so the first 3 numbers. So this is exactly what we want. So theoretical num plus equals I. So this would 0, 1, 2. Shouldn't we start at 1? Well, it's all the same, I think, because 1 or not, we still start. Doesn't matter. Okay, so for num in the nums, actual num plus equals num, and we take the actual num, subtract the theoretical num, and we should have our answer. Run. And it looks like it's good to go, as you can see here. Success. So to speed this up, we can find a better way to sum these numbers. So that would be to set this to be sum of all the nums. That's one of the functions. So that speeds things up a lot. Run it again and submit. So we're now at 67%. So the next thing we could do is to get this number more quickly. To do that, we know that 1 plus 2, 1 adding all the numbers all the way up until if it's continuous, all the way up until 10, you can add these numbers up, like 1 then plus 10, and 2 plus 9, and so on and so forth, all the way up until 5 plus 6, and get a total of 55. So this would be basically n plus 1, and you do it by half because you have half these numbers. So the formula is n plus 1 and n divided by 2. So you multiply these together, these numbers, and you would get all the way numbers added up to 10. In our case, we want to go 1 less than the nums because we want that 1 less number. And so we would go for n is equal to length of nums let's say minus 1. So that would be what we need. So we'll set that. and we can set our theoretical num to be n plus 1. Times n divided by 2. And that's our theoretical num. That's our actual num. So we can remove that and run. And we are good. We're currently at 100%. To make this even more streamlined, we can simply substitute this all into a single line. So first we could do a subtraction. So we comment this out, and we do a sum of nums minus this particular item here. And we substitute this particular n here and this n here. As we can see, these cancel out, so we can take that out, and we need to do a parentheses here to get this whole thing complete, and run. Let's see what happened here. So length of num, so we need this parentheses here, surround that, run. And we have a one-liner now. You can see that. And that is how we do detect the only duplicate in the list. I think we did it in O of n time and O of 1 space. Because the sums of all number takes O of n time. This takes O of 1 time. So O of n time is what we have, and O of 1 space because this requires one variable and this requires nothing. And that's all. Thank you for watching. If you like what you see, hit the like button. If you like the material that I am putting out there, please subscribe. If you have any questions, leave them in the comments below. I'll get to them when I see them. That's all. Thank you.